Now. So, hello everyone, welcome to this Men&Mice webinar. My name is Peter Pettersson and with me today is Carsten Strotmann. Today's webinar is focused on Bind version 9.11. This is a major version of the popular DNS server. And it is Carsten Strotmann from the Men&Mice services team that will do the presentation, deliver the presentation here today. And please note, everyone, that all attendees are on mute, but you can submit questions through the GoToMeeting control panel. We are also recording this session, and you can find the webinar along with the slides at our website within a few days. So if you drop off the call, you can just visit our website later on and see the rest of the webinar there. And at our website, you can find recordings from earlier webinars as well. So Carsten, you are still there?
I'm here. I'm ready.
The audience is yours.
Thank you, Peter. Hello, everybody. This is Carsten from the Men&Mice services team, and I have for you some updates on the new version of Bind 9, which is the 11th version of Bind 9 now. So it's still in beta. Bind 9.11 was originally planned to be released on 2nd of August, but there have been a few minor delays, and we expect this new version of Bind to be available any day now in August. So what will we talk about in this webinar is about catalog zones, which is a new way to provision slave servers. We have some new functions in the rndc, the remote name daemon control system in Bind 9. A new tool called dnssec-keymgr, which allows DNSSEC signing keys to be managed automatically, especially the rollover of these keys. Then we have the CDS and CDNSKEY auto-generation, which is a way to bring the trust anchor changes for DNSSEC into the parent zone. The negative trust anchors for DNSSEC, DNS cookies, and minimal any, among other things. So there's a lot of new stuff in Bind 9, 11th version, and I only have picked the stuff that I thought is of most interest for the Men&Mice users. If you really want to learn everything, at the end of the slide deck I have a link to the changelog, and there you can find all the changes that happened between this version and the previous version of Bind 9. So a big change, not on the technical side, but on the license side, is that Bind 9 is now licensed under the Mozilla public license. Previous versions from the beginning of the Bind software, which was in 1988 with Bind 9.4, all the time Bind was under the ISD license, which is a variation of the BSD license. Now, Mozilla public license. The big change here is that if you make changes to the Bind source code and you distribute the result, then you also have to open the source code, which is not needed with the old ISC license or BSD license. Both licenses are so-called open source licenses, and for the normal user there's no change at all. So Bind 9 is still free software. It can be downloaded, compiled, source code is available. So it only has impact on companies that make changes to Bind and integrate Bind in their product offerings. So first new feature is the catalog zones, and a catalog zone is a zone, a special zone that holds the names of all the zones that should be on a DNS system, including metadata information like configuration information, access control lists, IP addresses of the master servers in case of a secondary slave zone, and so on. Catalog zones are something that has been invented by ISC for Bind 9, but it's open. There's currently an internet draft, which is an RFC work in progress inside the ITF. And there's already a proof of concept implementation of these catalog zones for Power DNS. So we will hopefully see other vendors picking up this new function, this feature, and provide a compatible implementation so that we can mix catalog zones from bind, maybe with NOT and NSD and Power DNS and maybe Windows DNS in the future. So on the technical side, the catalog zone works like a normal zone. It has a SOA record, NS records, and some other resource records in there. And it contains the names and the configuration data for all the zones that should exist on the secondary server. The content of the catalog zone is maintained on the master server, and then it is zone transferred to all the secondaries, and then the secondaries will reconfigure themselves accordingly to the information in the catalog zone. So the big idea behind the catalog zone is that you don't need to touch the secondaries. Now, for users of the Men&Mice suite, this is nothing new, because the Men&Mice suite had that all the time. But if you only use Bind9 or any other DNS server without a management solution such as the Men&Mice suite, you always had to go to every instance of a secondary server, make config changes there for every new zone. Now, this is now simplified with the catalog zones. Let's have a look how catalog zones work. On the left side, we have a server with the master zone, and on the right side, we have a server with the slave zones. First, we create a catalog zone on the master, and the catalog zone is, in the beginning, it's empty. Meaning it has only a SOA record and the NS records. It has an NS record for every name server that hosts these catalog zones, very similar to a normal zone. So if you have a master and let's say 5 slave servers, then you have 6 NS records, 1 for the master and 5 for the slave servers there. And then this is what we need to do manually once, is we configure the catalog zone also on every slave server. And there we have a zone transfer, and also the catalog zone is empty in the beginning. Then we configure a production zone. Here it's the zone example.com as a master zone on the server with the master zones. And we put in the name of that master zone, example.com, into the catalog zone, telling the catalog zone that we want to have example.com on all our servers, including all the secondaries. We increment the serial number on the catalog zone because it's a normal zone. It needs, in order to distribute to all the secondaries, it needs to have an incremented serial number. And then zone transfer happening to the secondaries. And now the catalog zone on the secondaries also lists example.com, which triggers the production zone example.com to be created as a slave zone on that server. And that happens automatically. So no manual login with secure shell and changing the configuration of the name server, restarting the name server is needed. It all happened automatically. Then the slave server will do a zone transfer, getting the resource records of the zone, and now both servers have the same content. The same way, if we want to remove a zone, we just remove the zone from the catalog zone, and that gets then removed also from the slave servers. Here's an example of an empty catalog zone. As I told you, it looks like a normal zone. We have a SOA record there with the serial number, and all the values of the SOA record work accordingly to how normal zones work, and then we have the NS records, one for every name server that hosts the catalog zone. In the named.conf on the master server, the catalog zone is just configured as a normal zone. We see that here at the bottom of this configuration snippet of a named.conf file. Then we check the configuration, start bind, and check with rndc status that bind is actually running and has the zone loaded. And then on the secondary, there it becomes a little bit special. On the secondary in the named.conf, we have to allow Bind9 to automatically create new zones. That is with the allow new zones yes statement in the option block. And then we have a catalog zone block where we list the zone name catalog.example. Actually, we can even have more than one catalog zone in a bind configuration. That is possible. Then there's a zone directory. The directory here is cat-zones, which is the directory below the home directory at mdig, where bind will store the configuration snippets for all the automatically created slave zones. The in-memory parameter tells bind to also write down the configuration to the file system. If we say memory yes, the zones will only be created in memory and not written back to file. And then the default master is configured here, which is the IP address or the IP addresses of the master servers. The default masters can be overwritten by metadata in the catalog zone itself. The default masters are only used if there's no explicit other configuration in the catalog zone. And then at the end here, below the logging part, we have the catalog.example zone as a slave zone, with the master statement pointing to the IP address where our master server is. And that then distributes the catalog zone from the master to the secondary, and now we have an empty catalog zone on both servers, and next step is to create a production zone. Here I have a simple zone called example.com, has a SOA record, NS record, and 2 A records for the authoritative servers in my test environment. Nothing special here. This is then configured in the master. The zone example.com, master loading from the file example.com. And then we check configuration and reload the bind name server. And then we put, and this is the new stuff, the new zone in the catalog zone. In order to do that, we need to have a SHA-1 hash of the zone name, or actually it could be any SHA-1 hash of any text string or any other data. This is just there to have a unique value for every zone in the catalog zone. So here I used OpenSSL to calculate the SHA-1 hash of the string example.com. And then in the catalog zone, we increment the serial number because we make a change to the catalog zone. And then with the domain name of hash.zones without a dot at the end, so it is a domain name that will have the zone name appended. So the full domain name is hash.zones.catalog.example in our case, a pointer record to the name of the zone. And this is all what's needed, one pointer record pointing from the hash to the name of the zone, and that registers the new zone in the catalog zone. Now later on we will see that with the hash we can store more metadata on the name. Actually the hash later on will provide the link between the name of the zone and the metadata stored in the catalog zone. And once we do this and we reload the catalog zone, because the catalog zone has a higher serial number, that gets transferred over to the secondaries, and then the secondaries reconfigure themselves, create the example.com zone, and the example.com zone will be transferred over, and all the servers are now configured with the new zone. That's fine. This is what we want. So we can store more metadata here. We can link that to the hash we have used. For example, we can put in one or more IP addresses for masters for the catalog zone. That is with the masters dot and then the hash.zones A record. We can have multiple of these A records. We can also have quad A records for IPv6. And we can have access control lists here for allow transfer. Also, we could do that for allow query or for allow recursion with the APL resource record. The APL resource record stands for address prefix list, and it's a generic address record that has been in DNS for a long time, more than 20 years, but never really been used. The catalog zone make now use of this. Actually, what we can do with an APL resource record is we can give a list of address prefixes, both IPv4 and IPv6. And this is the address prefixes that are then be used to create the allowed transfer access control list. There is a new rndc command called rndc zone status. And if we call that on the slave server where we have the catalog zone, we'll see that example.com exists. It's a slave zone, and the file that is backing up this slave zone is in cat zones __ cat z for cat zones __ default, which is the name of the view, _catalog.example, which is the name of the catalog zone from where this zone originates, _example.com db, which is then the configuration for the example.com file. And this is where the zone file, the zone data will be stored. The serial number is currently 1001. It's last loaded, next refresh. It expires if there's no refresh on the 26th of September. And it's not secure, so it's not DNSSEC signed, it's not a dynamic zone, and it can be reconfigured with modzone. A little bit more about modzone later. So that was the catalog zone. We already have seen a new command with rndc. There's some other new stuff with rndc. First over, rndc can now make read-only, and that is with the read-only yes option in the control statement. That creates a read-only rndc control channel where all destructive rndc commands are blocked. So no reload, reconfigure, stop, or add zone or del zone, but you can do rndc status, rndc show zone, and so on. So you can query information about the bind server or zones. You can also look on DNSSEC trust anchors, for example. You can have multiple control channels, so each have then its own TSEC keys. So the administrator can have an rndc control channel with all power, that is even to reconfigure the name server, and maybe support can have a channel and the key that is read-only. So since a few versions, it's possible in bind 9 to create new zones with rndc, with the commands rndc add zone, and to remove zones with rndc del zone. This has now been expanded. A zone that has been created with rndc add zone can now be changed dynamically with rndc mod zone. And it works the same way. You give, after rndc mod zone on the command line, the full block, configuration block for the zone, and this overrides the existing configuration on the server. Another change is that rndc del zone can also now remove zones that are directly configured in the named.conf. But be aware, bind will not rewrite the named.conf. The zone will be disabled in the running bind named instance, but whenever bind is restarted, that zone will appear again. So if you really want to have a zone to be removed, you have to still go to named.conf. But what you can do with this is you can, on a running name server, disable a zone temporarily, and then with an rndc reload, it will appear again. And then there is rndc zone status, where we can query information about the zone. This is a static configured zone here, example.com on the master server. We see the serial number here when it was last loaded, whether it has DNSSEC, whether it's a dynamic zone, and whether it can be reconfigured with mod zone, which means rndc mod zone. There's now a Python library for the rndc channel, and that allows people who write Python code to use the rndc control channel to talk with the bind name server from Python applications. So you can if you write a Python application, you can make use of the rndc functions like manage DNSSEC keys, sign zones, do add zone, del zone, mod zone from directly within your Python application without the need to call the rndc binary. Some changes on the DNSSEC side. There is now DNSSEC Key Manager, which is a new tool written in Python to manage the DNSSEC keys and the rollovers of these keys. It works on a policy file, which is in the configuration directory, which is by default /etc, but on popular Linux distribution could be etc bind, or on FreeBSD would be etc namedb, and then policy.conf, which is the default file name for the configuration. And this configuration will define one or more policies of how DNSSEC signing should be done. It defines the key sizes, the key algorithms for DNSSEC, and the rollover intervals, like roll the ZSK every 30 days and the KSK every half year, and so on. Policies can be defined as global policies, acting for all the zones, can be configured per algorithm and per zone, and policies can also inherit settings from global policy definitions. I will show you an example in a moment. Here we have that example from the policy.conf file. In the beginning here, we define the default DNSSEC policy. We give a directory where we want to store the keys. We want to have RSA SHA-256 crypto algorithm to create our keys. The zone signing key should be a 2048-bit key, and the key signing key a 2560-bit key. We want to pre-publish the zone signing key 1 week before it becomes active, and we want to post-publish the zone signing key 2 weeks, meaning it will be removed 2 weeks after it became inactive. The roll period of a zone signing key is 2 months here, and the roll period for the key signing key is 0, meaning we don't want to have automatic key signing key rollover. We want to do that manually. And the coverage is 364 days, meaning in that day from beginning active, the keys will be managed by this policy. If they are older than 364 keys, but still in the directory or in the zone, they will not be touched by this policy. And then we have a second policy here, a zone policy for example.com. And we inherit the default DNSSEC policy, but we change the key size for the zone signing key to the lower 1536-bit, just as an example how to override values from the inherited policy. DNSSEC Key Manager is designed to be run from a cron job automatically, like once a day. It then inspects all the keys in the key directory, creates new keys if needed. It will not directly interact with the bind server. Instead, it will just set the timing event on the keys, and then bind will read the timing event from the keys and will then act accordingly to whatever is in the keys. Here's a run directly from the command line where it has created the keys for example.com and also the successor keys for the next rollovers. With rndc managed-keys status, we can list all the trust anchors configured in DNS resolver. So if we have bind running as a DNS resolver, as a validating DNS caching server, it needs to have one or more trust anchors. And trust anchors can change because the key signing key of the start of the trust chain changes, which will happen for the root zone in the next year. And in order to verify that maybe the new key has already been imported by RC 5011 automatic trust anchor update, we can use rndc managed key status to see what trust anchor is currently being configured and how long is it trusted and when will bind check next time whether that has changed. So here in my example, we have a trust anchor for dot, for the name dot, which is the root zone, and the key ID is 19036, which is the old root key signing key. And hopefully over the next months that will change and the new one will be imported, and we can see that with rndc managed key status. A big challenge for the root zone operators and also for all people operating a domain that is being used as a trust anchor is to know which DNS resolvers already have the new keys in case of a key signing key rollover. Because there was, as so far, no feedback channel where a caching server could tell the operator of a domain whether a trust anchor has been updated. And in bind 9.11, there's now DNSSEC trust anchor telemetry, meaning that once a day, a bind server configured as a DNS validating resolver will send a specific query starting with _TA for trust anchor and then -key ID -key ID dot domain name to the domain for which the trust anchor is configured. This is mainly aimed for the root name server operators now, because that will enable them to get information from all the, at least from the updated bind installations worldwide, whether these servers have successfully then picked up the new root key signing key in next year when the root key signing key will be changed. If you don't like that, if you don't want your bind server to talk to the operator of your trust anchor, you can disable this with trust anchor telemetry no in the configuration file, but I highly recommend to keep that enabled, especially if you're running your bind server in the context of the internet DNSSEC, because the operators of the root zone, they need this feedback to make an informed decision when they can remove the old key signing key from the root zone. Now bind 9.11 has a new supports the new CDS and CDNSKEY resource records. Both records are there to allow automatic provisioning of the DS record in a parent zone, creating the chain of trust from the parent zone to an actually DNSSEC signed zone. Without this, the DS record or the DNSKEY record needs to be manually sent over to the operator of the parent zone, which is error prone and takes time, and all bad things can happen there. Now with this CDS and CDNSKEY resource record, this can be done automatically. Bind 9 is the first DNS server to support this new RFC. So it will probably take some more months until operators of parent zones, top-level domain zones, will support this scheme and will accept CDS and CDNSKEY records from child zones. So how does this work? In the old way of managing DNS, if we have a new key signing key in our own, which is the child zone, we have to create the DS record manually and then send the DS record to the operator of the parent zone. And they put the DS record in the parent zone to update the chain of trust. This is manually work because it needs to be created manually. It needs to be sent by email or via a web form. All things can go wrong. With the CDS CDNSKEY, the DNS server just publishes the new DS record or the new DNS keys that should be used by the parent in the own zone, sign that with the existing DNSSEC key, and the name server of the parent DNS, they pull the child zone. When they see a new CDS or CDNSKEY record, they automatically fetch that, create the DS record, change the DS record, and everything is updated. This can be fully automated. There's no need to for manual intervention, not on the child level and also not on the parent level. Makes life easier. In order for that to work, Bind 9 now supports additional events that can be set with dnssec-keygen or dnssec-settime, and these events give the time and date when the CDS key should be published first, and the sync delete gives the event when this data can be deleted again. And we can set this with -P sync for the publish time, and with -D sync for the deletion time. Here in this example, I set the publish sync 3 months from today on the key with the key tag 58464. And when I do a print all on this key, we see that the sync publish time is now November 16th, 9 o'clock 47 GMT, and this delete time is currently unset. One struggle with DNSSEC validation is sometimes that the operators of a remote zone mess up their DNSSEC configuration. For example, they change the key signing key without updating the delegation signer record in the parent, or they forget to re-sign the zones. So signatures become stale and the domain does not validate anymore. This has happened a lot over time in the past and was a problem for operators that are operating a validating DNS server, because so far there was no way to disable a DNSSEC validation for a specific domain. Now there is. Now Bind supports negative trust anchors, and a negative trust anchor is a bit of configuration that disables DNSSEC validation for a specific domain and can be used by the operator. And if the operator detects there is a mess up in a DNSSEC zone, in a remote DNSSEC zone, to override DNSSEC validation for a certain amount of time. If a negative trust anchor is configured in a Bind server, then that domain and all names that are below that domain are processed as if there would be no trust anchor or no trust chain. The negative trust anchors are stored in Bind, so they are persistent across restarts, but they time out. So it's not possible to put in a negative trust anchor that is in the configuration forever. This is done intentionally because negative trust anchors are just a temporary workaround until someone has fixed the domain. So there is a lifetime that we have to specify when we create a negative trust anchor, and the maximum we can specify is 1 week. If a zone, a DNSSEC zone is not fixed after 1 week, there is probably no interest in that zone, and we should probably disable that zone completely and not query it at all. But usually an NTA, negative trust anchor, has a much lower lifetime. Also, Bind 9 checks in the background periodically if the domain validates again. Once it validates again, the negative trust anchor for the domain is removed automatically. So as an operator, I can just set a negative trust anchor and forget about it, because it will remove itself after some time. Here's an example for how we can create a negative trust anchor with rndc NTA, negative trust anchor, -L for lifetime, and then the amount of seconds how long the trust anchor should be valid. Here in this example, 60 seconds, maximum is 1 week, and the domain for which the negative trust anchor should be in there. Here, fail01dnssec.works, which is a domain that is deliberately broken for testing purposes. And we see that the negative trust anchor has been added and will expire on 18th of August, 1 o'clock 52 seconds GMT. That is already done. With rndc NTA -dump, we can dump all the negative trust anchors that are currently configured. And the negative trust anchors are stored in the sysconfig file directory, and there a file with _default.nta for the default view. If you have multiple views, you have then multiple files with the name of the view .nta as the extender. If you want to remove a negative trust anchor, we can do so with rndc nta-r from remove, name of the domain, and then the negative trust anchor is removed from the file and from the running config. So that was the DNSSEC part. Now a new concept that has been implemented in Bind 9 is the DNS cookies. DNS cookies is now an internet standard. RFC 7873 is the lightweight session over UDP that between the DNS client, which can be a DNS caching server or DNS resolver, and another DNS server, which can be another resolver or can be an authoritative server. And DNS cookies can be used to mitigate cache poisoning attacks, and it makes DNS amplification attacks harder. The problem with UDP and the DNS is that it's just a two-way communication. It's just a query packet going out to the server and an answer coming back, and that makes it easy for attackers to just spoof the source address of the query and send the answer to a victim. With DNS cookies, this is then mitigated. How does it work? On the server side, we can either manually configure a secret, which is recommended if you have an Anycast cluster, or if you don't configure a cookie manually, then the bind name server will calculate the server cookie automatically on startup. A client on the first query to a DNS server, it will put in the EDNS OPT section of the query the client cookie. The client cookie is built from a random data plus the IP address of the client, and it should be stable for the client for a certain amount of time. And it puts also, if it has, the server cookie hash for that server it is sending the query to. Now in this case, the client is sending the very first query, so it doesn't have any server cookie, so that hash is empty. Now the DNS resolver here is configured to not answer any queries where the server cookie hash is empty. So it will respond with an empty response with an error code of bad cookie. Now this error code comes also in the EDNS section, and it includes the server cookie hash. The client now can cache the server cookie hash and resend the query now with the server cookie hash, and this tells the server that it had contact with this client in before, and that the client actually received the bad cookie response, meaning that the client does not use spoofed IP addresses. And now that the server cookie hash is there and it's valid, it matches the secret on the server, we get actually the response back. It's a no error response with all the data that has been requested, A records, MX records, whatever has been requested, and it includes again the server cookie hash, because the server cookie will change from time to time. It will be sent with every response being returned to a client. We now see the DNS cookies in the dig output. So if you use dig from 9.11, you see in the OPT pseudo section a line cookie colon and then the full cookie, which is the client cookie plus the server cookie, and then in parentheses good if dig could even validate that this is the correct cookie sent back from the server that it had a previous connection to. Also, the cookies are enabled on the server side. So a bind server 9.11 will send DNS cookies with every communication unless you tell them not to do. What we can configure in the bind configuration file is require server cookie. If we set that to yes, then the bind name server will not answer over UDP if there is no cookie in the query. Now, this is nothing we can do at this point of time because not all the clients support cookies, but it might be possible in a later time. Send cookie, we can set that to yes, and then the cookie will be sent with every query going out to an authoritative server. We can set the no cookie UDP size, and with that we can set the maximum size of a UDP response that is sent to queries without a valid server cookie. Now, this is interesting because that can mitigate reflection attacks and amplification attacks. We allow larger answers, maybe DNSSEC answers, only to clients that use the cookies, and other clients just get smaller UDP answers, or they get a truncated answer and have to requery over TCP. We can configure the cookie algorithm, which is by default IS, but it can also be SHA-1 or SHA-256. It's the way how the server cookie is being generated. And we can manually set the server cookie. That should be done in an Anycast cluster system. In a non-Anycasted environment, we can just have bind create a cookie automatically. So that was the DNS cookies, and now I have some miscellaneous. New resource record types that are now supported. OpenPGP key is a way to store PGP public keys for email addresses in DNS. This is part of the DANE standards. Then we have AVC, which is a new resource record that is storing metadata about applications. It's coming from Cisco for the DNS AS, DNS Authoritative Source. I have no more information what this is about. It's relatively new. I'm interested looking for what comes out of this new resource record. And then we have TA and TA link, ninfo, rkey, and sync, which are all new resource records that have been defined for many, many years and are just now implemented in bind for completeness. I'm not aware that any of these records are being used in production environments. But now they are there. Maybe you can look them up and check if they are useful. What's definitely is useful is the minimal any. A bind server that is getting a query with query type of any, which is query type 255, will answer with all the resource matching the requested domain name. And the any query type was originally designed as a troubleshooting tool to help operators find errors in the DNS. But in the past years, it has been misused by attackers to create large responses. Like here, if we ask for Men&Mice.com query type any, we get a response with all the Men&Mice.com resource record, which includes some TXT records with some tokens required, the SOA record, A record, and so on, quad A record, and it's an answer of 719 byte, which is for DNS quite large. With the new bind version, we can configure minimal any yes, and this will not disable the any processing, but it will slim the any responses down to the minimum possible. What's happening here is that bind will now just return the first entry of a matching any query. That is, it will just return one record in the answer section and not all of them. So this disables the troubleshooting ability of the any query type, but it mitigates two reflection attacks and DNS amplification attacks by doing so. So here's the same query for Men&Mice.com against a server that has minimal any enabled, and here we see we only get the SOA record back in the answer section, no TXT records anymore, no A record, no quad A record. And the size of the answer is now 123 bytes versus 719 byte, and this is much, much better. it's much harder to launch a denial of service attack with 123 bytes UDP packages. Adaptive preferred glue. Sometimes a bind name server needs to, or any DNS server needs to return glue records, which are A record or quad A records in the additional section when giving out a referral, that is when pointing a caching server towards a delegated domain and the name service for a delegated domain. Here, sometimes there's too many datas, too many A records and quad A records to fit into one UDP package, and then the name server must decide whether to prefer IPv4 or IPv6. In the past, with bind, you could tweak the preferred glue manually in the configuration file. You could either prefer IPv4, or which was the default, or prefer IPv6. Now, this is kind of self-tuning. Bind 9.11 will use preference for the transport protocol where the query was received. So if the query comes over IPv4, IPv4 glue is being preferred. If the query is received over IPv6, then the IPv6 quad A records are preferred and put in the additional section. This came to a little surprise to me. nslookup got updated. The old tool that has been around for ages, and it hasn't seen any update for the last, I think, at least 20 years, as far as I can remember. What has been changed here is that nslookup will now look up both IPv4 and IPv6 information if you type in a host name. So yes, nslookup has learned how to deal with IPv6. A small step for this tool. Doesn't mean that you should abandon dig and use nslookup again. Please don't. Forget about nslookup and use dig all the time if you can. SERVFAIL caching. Normally, a DNS server only caches NX domain and no data responses, and not server fail. However, if there is a failure on a remote name server, and there are a lot of clients asking for a domain there, this can be a server fail answer can be a burden for a recursive server if the server must go out to the authoritative server all the time. Now bind is for a very short amount of time is caching server fail answers, by default 1 second, maximum is 30 seconds. And that reduces the load on big DNS results. It's probably, you don't see a difference if you have a modest installation with maybe hundreds or thousands queries per second, but if you have 10,000 queries per second, million queries per second on your infrastructure, then this can really help. There is a new tool called mdig, which is the big brother of dig. mdig stands for multi-dig, and can be used to send multiple queries at once towards a DNS server, and the answers will then be printed in order of arrival. Now, this has limited usefulness today, but it is a preparation for a change that will come to DNS in the future, which is that as it looks like from new protocol development in the ITF, in the future DNS will more and more also be done over TCP and maybe TLS secured, and there a technology called pipelining will be used, which allows then multiple queries to be sent over the same TCP connection, and this multi-dig can then be used to make use of pipelining if you send multiple queries towards the same server. Here's an example how multi-dig looks like. mdig, you have to specify the server you're sending the query to. mdig is not looking at the etcresolve.conf. You always have to specify the server to send the queries to, and then a list of domain names you want to query. Here, 3 queries for men&Mice.com, and it prints out the answers in the order they are coming in. There is a couple of new dig switches, and I picked just one. which I find quite useful, which is the plus TTL units. And if you use dig with plus TTL units, it will print out the time to lives not as seconds, but as human readable values. So here we see Men&Mice.com is in the cache for 4 minutes and 54 seconds. And the NS records for Men&Mice are in the cache for 20 hours, 52 minutes, and 59 seconds. So this helps a little bit troubleshooting cache contents. This is one change that came actually out of the ISC and Men&Mice trainings. In the trainings, we very often had the problem that the training attendees were starting the bind process multiple times, which is then has the curious effect that the first started instance will answer on port 53, and the last started instance will have is the one that will react on rndc. And that created a lot of confusion. Also, I've seen customers struggling with that in production environments. Now, bind, especially the named process, will refuse to start if it cannot bind to any network interface, meaning that if there is already another DNS server running on port 53, which might be another bind or might be some other DNS server, it will then just refuse to start. Or if there's a log file that already exists and the default directory for the log file is var run namd.log, and as always, you can configure that either on the command line with the command line switch or in the configuration file if you want to have the log file in a different place. Useful, especially in our training environments, but also in production environments. Here we have an example starting named in the foreground, and this was a server where bind was already started. So this instance of bind tried to open port 53 on all the network interfaces. It failed on all of them, and then it stopped starting up and exited due to fatal error, which is new. Older versions of bind would just start up and not function properly. As mentioned, there are more changes. This is just the highlights that I picked out of the changelog, and here's the URL to the official beta 3 changelog. I would recommend that you take a look there and browse through the document and see if there is other interesting changes that that are useful for your environment. So this was the overview of bind 9.11 changes. A few information about our upcoming training classes. We have a Kia DHCP training class on the West Coast US in October, and one on East Coast, and one in Amsterdam, the Netherlands. It's a 2-day hands-on training for all people who want to learn the new Kia DHCP, which is the successor of the ISC DHCP. And we have our DNS and bind training, which has been all updated with over 100 new slides covering all new stuff from the latest IETF DNS protocol changes and also bind 9.11 changes. We have one in Arlington, Virginia in beginning of October, and then one in Germany in the Linux Hotel in Essen, which is the second week of October. And our next webinar is already end of August, so a second webinar is this month. It's about best practices in creating a secure bind 9 environment. We talk about the change root versus container. So what is more secure, why maybe container is a more secure way to isolate a bind name server, and we will cover different container technologies from Docker to systemd to FreeBSD jails. We talk about separating, resolving, and authoritative services and why this is important to do. We give hints on configuration options that you can tune in bind 9 to secure your bind, and how you monitor bind 9 for security issues. We give tips on doing that, give you links to the mailing lists and so on. And that will happen on August 31st, which is a Wednesday, same time as today. And this concludes my webinar for today, but first have a look if we have any questions. Peter, are you there?
Yes, I'm here. Thank you, Carsten. This was really interesting. And while I'm waiting to see if the attendees have questions, maybe just a quick question from me. Bind 9.11, that seems to be quite an upgrade, but what happens then on the Bind roadmap? Can you share with us any intelligence there, Carsten?
I'm not prepared there. So of course there will be Bind 9.12 and 9.13, and there is already a roadmap for that. Usually there is 2 years between major releases. So Bind 9.11 coming out this year, then we will expect 9.12 in 2018 and 9.13 in 2020. What I would expect, without having looked at the IC roadmap, is to see more secure communication in Bind. There's a lot of discussion in the ITF, in the engineering task force nowadays, about encrypting communication, DNS communication, and using TCP instead of UDP for that, and using transport layer security, TLS, which we know from HTTP and other protocols. This partly already has been standardized, partly the protocols are still being in discussion, and Bind being the reference implementation of DNS for the ITF, as soon as all the relevant protocol bits and pieces have been standardized as an RFC, we will see them implemented in the upcoming Bind version. And because switching over from UDP to TCP, a major part of communication, that's a major change, and I will expect that happening in the next major release version of Bind, so 9.12 in 2018.
Very good. So
but there is a presentation from Victoria Risk, which is the product manager for Bind at IC, from the last RIPE meeting. That was in Copenhagen. I've written a blog post that is on the Men&Mice blog about that RIPE meeting, and it contains the link to the video and the slides of that presentation, and that presentation has the roadmap for Bind 9.12.
Very good.
So look at the Men&Mice blog.
Excellent. So I got one more question here from Jim. If there is a new version of the Men&Mice suite beyond 7.2, and I can address that one. We will have version 7.3 shipping, I think late September or early October, adding some nice features there. And in 2017, we will have 3 new versions. It will be 8.1, 8.2, and 8.3 as well. So we have a roadmap and new versions coming. But there are no further questions from the attendees today, and we've already filled the hour, Carsten. So I would like to thank you, Carsten, for this presentation, and I would like to thank all the attendees attending today, and hope to see you guys in our future webinars as well, the next one in 2 weeks' time. So until then, have a nice time.
Thank you. See you next time.